Division of labor can arise spontaneously. It's inescapable under certain circumstances. When you get individuals to cohabitate a nest, some individuals have different response thresholds than other individuals for different stimuli. So some are going to be performing, one set of behavioral acts more than another individual will perform those behavioral acts. A good example is the spontaneous division of labor that can be generated in Serotina flavipes. Serotina is the smaller carpenter bee. They nest in the pithy centers of certain kinds of stems, as shown here. Oops, here. And here they're boring out the center of this stem. It's very pithy in the middle of it. And they burrow down, and then they start constructing cells. So this is a female. The females build the nests. They're completely solitary. They live their lives on their own. But when they get down to build a cell, they'll then forage. They'll collect pollen and nectar. They return to the nest, and they will produce some sort of a ball of pollen with nectar in it. It's called pollen bread, and lay an egg on top of it, and then they'll seal it off, and then they'll build the next nest. And so they do this sequentially up the stem. As I said, that the species, the females, nest alone, and you don't find them nesting together, but you can force them to. And this is an experiment that was done by Sakagami and Maeda. They took these Serotina and they forced them into a cage and provided them with very few opportunities to build a nest. So there were more females in the cage than there were opportunities for nesting. And they found that they would actually pair up. They would work together. And in every case where they were able to get two females sharing a nest, they ended up with a division of labor. One individual became the primary forager, and the other one became the primary egg layer and guarded the entrance. And this was the division of labor that occurred whenever they got more than one together. It was inescapable. It was something that wasn't pre-selected. It's just a consequence of the fact that they had different response thresholds, and they were responding to the stimuli in their environment. It's also true with Pogonomyrmex. This is the harvester ant. You find them in the deserts of Arizona. And again, the queens, this is a queen, when they emerge and after they mate, they start excavating a nest. And they are solitary. They go through what's called a claustral phase. They excavate the nest. They lay a few eggs. They catabolize their muscles, their wing muscles, which they no longer need their wings. They've lost their wings. And they provide for the first few individuals, very small workers that then come out of the nest, and then they start growing the nest very slowly. But they nest alone. If you force them into nest associations where you have two nesting together, again, you always get a division of labor. One will become the primary excavator, and the other one become the primary egg layer. So a spontaneous division of labor emerges, a very simple one, but it was one that was not built over time by natural selection. They got it for free. Thermoregulation in honeybees, this is a more complex behavior. This is one that has evolved over time, but honeybees will thermoregulate their nest. They maintain a near constant temperature inside the brood nest year-round. That's not true. Not year-round. During the winter, when they don't have brood in the nest, the temperature will actually get reduced. But while they're raising brood, they maintain a constant temperature. When the temperature goes up and it gets too hot, they thermoregulate the nest basically with an evaporative cooler system, like our swamp coolers that we put on our roofs and cool our houses. Some individuals collect water, they bring it back, they spread it throughout the nest. Other individuals sit at the entrance and fan, and they build a circulation through the nest. So that circulates the air through, there's water in there to evaporate, and it cools the nest down. Some individuals will thermoregulate, others don't. The ones who thermoregulate, who start this fanning action, are individuals that have lower response thresholds to the temperature. Then when they lower that temperature down, if it gets low enough, everybody stops fanning. And if it goes up again, those individuals that are more likely to fan because they have lower response thresholds to temperature will begin fanning again. Response thresholds to stimuli are not fixed. They're very, very variable. They're changing all the time. They vary as a consequence of age. And in honeybee societies, individuals change the tasks that they do as they age. And associated with this change in age are changes in their response thresholds. Also, as individuals age in a honeybee colony, as they age, they change their location. They initially emerge as adults in the center of the nest, in the brood nest, and they engage in tasks that are associated with the center of the nest, like cleaning cells and nursing larvae, etc. But then as they age, they go out further and further from the center, and they engage different stimuli, and they engage in different kinds of tasks that are associated with the periphery of the nest as opposed to the center. So their location is where they encounter the stimuli, and at age, they're moving and they're also changing their response thresholds. They also change as a consequence of prior experience. Learning can modulate response thresholds. Sensitization, habituation, which are other forms of behavioral change, having been exposed to different stimuli, they change. And also genotype. The genotype of the bee, the genetic complement of the worker, has an effect on her responses to stimuli for any given age and any given location where she might be. Keep in mind that a honeybee queen mates with many males, 20 or more males. Every one of those males has a different genotype or genome, and it's contributing to that colony. So every worker is slightly different. They're different because of the recombination that took place in making the eggs in the queen. Every egg is slightly different. And then from the different males that contribute to them. So they're all different. And these genotypes also have an effect on response thresholds to stimuli. So as an individual ages, her response thresholds for who knows how many, hundreds, thousands, millions maybe, stimuli that they encounter in their nest, their response thresholds to those different stimuli change. So this reflects just 4. So we have 4 response thresholds that are affecting the probability to respond to a stimulus. As this individual ages, they change. And these two individuals are different from each other. So they're different from each other to begin with. They're changing. The individuals are different ages, different experiences that have changed their response thresholds. And then at some point in time, they initiate foraging, and perhaps this set of thresholds here, this set of thresholds would result in being a pollen forger. Perhaps this set here would result in a bee being more oriented towards collecting nectar. But these things change over time, and then they're affecting probabilities that individuals perform different tasks within different age classes. Through this, you get a division of labor. So you can look into a honeybee colony, and you can look at the social organization, and you see that some bees tend to collect more pollen and less nectar, and other bees might be guarding the entrance, and others are engaging in undertaking behavior. They're removing dead bodies from the nest. Some are engaged in feeding larvae, and others maybe are building comb. And these different tasks that they're performing are a consequence of response thresholds to the stimuli that they're encountering where they happen to be. That's a consequence of a lot of different things: age, genotype, prior experience, etc. When you look at the age trajectory of a honeybee, you see that there's an age-related division of labor. As bees age, they tend to change the tasks that they do, and not just randomly, but in some sort of a trajectory that you can observe. So when they first emerge as adults, when they're very young, the first thing they might engage in is the task of cleaning cells. In the middle of the brood nest, they're cleaning the cells where other workers have emerged as adults, and they're preparing it for the queen to lay an egg. So they may engage in that. And then the next set of tasks they might do would be, being a nurse bee. They're feeding larvae, but maybe they're still doing a little bit of cell cleaning, and maybe they're doing a little bit of nest repair, but it's sort of a mix, but primarily focused on feeding larvae. Then when they get here middle age or whatever on their age trajectory, then they start engaging maybe in more tasks that are located out at the periphery of the nest. Remember, they're going from the center out to the periphery as they age. Out here, they're engaging things that might result in processing nectar, packing pollen into cells. These are done in the outer edges or further out from the brood nest. Packing pollen in the cells. They may be constructing comb or repairing comb. And then after their third week of life or so, they will initiate foraging. And when they initiate foraging, they will be going out of the nest. They leave the nest, they fly around, they collect pollen and nectar. And once they start foraging outside the nest, they seldom engage in any of the tasks within the nest again.